the email here, like making sure you're comfortable finding angles, reference angles, converting between radian and degrees, coterminals, stuff like that. Can we do that first?
Sure.
Okay. So let me give you an angle. I'm going to give you kind of the most difficult one. Let's say I give you an angle of minus I don't know, 13 pi over 6.
Great.
And I want you to figure out where that is in the unit circle here. And I want you to find, so figure out where it is. So you want to draw it.
Yeah.
And then the second thing is I want the reference angle that goes along with it.
Okay.
So give yourself 60 seconds and I'll jump in and help as needed with that.
Okay. Do I have a good pencil? Let's see. Give me 1 second. I'm gonna grab a good pencil. You done? No, I still have like half an hour. Okay, I'm back.
Okay.
So, ooh. Don't you have to give me such a difficult problem? All right.
Well, I mean, this is a way to know if you've got it or not. This covers a lot of things, and I can make it easier or even harder.
That's fine. It's fine. So we're going this way because it's negative. So. Okay, I think that's 13 over 6. Yeah, I think I got it.
Okay, so the first thing is that when you're going negative, pi is over here, or negative pi is over here. This is negative pi over 2. This is negative 3 pi over 2. This is our review, and this is negative 2 pi.
Mm-hmm.
So I'm going to draw the correct answer, and then if you didn't get this, we can talk about it. So it's in the 4th quadrant here.
Yep, I got that.
And then the reference angle is pi over 6.
Over 6. Yep.
Great. Okay. So now we can move on to doing some other things like finding some coterminal angles. I don't know why this isn't giving me more space. It's really weird. So let's look at another problem here where I tell you that the angle, the given angle that's given here is let's go with 21 pi over 4. And I want 1 positive and 2 negative coterminal angles.
Okay. Wait, so we could just have what? So you want those 2 negative coterminals. You want the numbers. You want it to be like negative. For example, negative 3 over 4 pi. I don't think that's right, but that's an example, correct?
Yeah. Yes, exactly.
Okay.
It should have a negative in front with 2 of those.
Okay. Okay, and then one more. Sorry.
I'll be right back. Okay. Do you have some answers yet?
Yep. So for my positive, I have 29 pi over 4.
Okay. That's fine because you can add or subtract 2 pi. I'm going to subtract 2 pi, which is 8 pi over 4. So that's that first, like the one I would write is 13 pi over 4, or I would keep going and get pi over 4. And then, like you said, when you subtract again, you're going to get minus 7 pi over 4, hopefully.
Mm-hmm.
Actually, this is wrong. I'm sorry, this is 5 pi over 4. And then this would be 3 pi over 4 because you were right. And then minus 11 pi over 4.
What?
So 21 pi over 4 minus 2 pi each time gives you 13 pi over 4, 5 pi over 4, and then minus 3 pi over 4, and minus 11 pi over 4.
Okay, that's not what I got. I got minus 2 pi over 4 and minus 10 pi over 4. I don't know where I'm going wrong there.
Just a subtraction error.
Oh, 24. That's my bad. It's not 23. 8 times 3 is 24, not 23. Okay, yep, I see where I did wrong there.
All right. So let's do a couple
How
more
did
here.
I guess that though? That was impressive.
Let's say the angle that I give you is minus 910 degrees. I want you to do the following. I want you to draw it. I want you to find the reference angle. And then I want one positive coterminal. And these need to be between minus 360 and positive 360.
Yep.
And then I want one negative coterminal. Same thing, minus 360 to.
Okay, let's draw that first. So. What? Okay, I have it.
All right, so when I draw this.
Oh wait, I don't have the coterminal. Sorry.
Okay, give yourself a little more time.
Ooh. Okay, now I do.
Okay, so you're going to go all the way around. That's 360. And then you go all the way around again. That's 720.
And then it's just past that third. It's just barely into the third quadrant.
Yep.
And then the reference angle should be 10 degrees.
Agree.
And then for the positive one I got was 170 degrees.
That's right.
And then for the negative, 190 degrees.
Good. Yeah, sometimes it's helpful to redraw them for that. For when you're doing coterminal and not. It looks like these are the right difficulty for what you might see on a test or quiz.
Right.
But there are more difficult ones in this that a good math student like you might want to know. So it looks like your instructor here uses n for finding a coterminal.
Yes.
And you'll just want to. I'll just write that down again just to emphasize that coterminal is your angle plus 2 pi n if it's in radians.
Yeah.
Or it's your angle plus 360 n if it's in degrees.
Mm-hmm.
Now, there's a few things here that I think you'll appreciate that could be weird. I could give you an angle and say your angle is 40 pi degrees.
Okay.
And that's totally legitimate. It's weird.
Yeah.
but your school has what they commonly ask, and I could also give you an angle and say that it's 6 point, or I could just say that it's 6 radians is your angle.
Mm-hmm.
And this is in radians, obviously, and this one's in degrees. And what they do is they mix the two to try to make it unclear. And they often ask you, like, what is the difference between, what is 2 pi radians? What is 2 pi degrees?
Okay.
And 2 pi, like here, like if you convert this to degrees, do you remember how to do that?
No, not really. It's just times 180, right?
Over pi.
Okay.
So this is 360 degrees, and that's a full circle.
Yeah.
Okay, yay, full circle. 2 pi degrees, well, it's already in degrees. So 2 times pi is approximately, I don't know, 6.29 degrees.
Mhm.
So that's like this.
Mm-hmm. Yeah.
I can't remember exactly how it's asked, but it's something like this. And often you have to be okay with the idea that pi could appear in radians or degrees. They could also say like what is 6 radians? And that, again, if you convert that to 180 over pi, it's about 3 revolutions of the circle.
Really?
So okay. Then your class goes on to, so you start talking about circles. And there's really two things you can talk about with circles. One is the arc length. Okay. And if you go all the way around, it's the circumference.
Mm-hmm.
Okay. And then there's the sector area. And if you go all the way around, that's the area of the circle.
Mm-hmm.
So we're either asking you to like take a walk around, or we're asking you how much is there. That's drawing.
Yeah.
How much sorbitly. So then, so briefly, I'm going to give you a couple of problems here. Let's say that, and I'll just draw it this way. This is theta is more commonly used, and this is r, and this is s, and you know that s equals r theta, but theta is in radians. So this problem works out really well if I give you a problem and I tell you that this is pi over 4 and this is 16. What is s?
Okay.
Give me that value.
It's pi over 4 times 16.
Yep.
It's 4 pi.
Right. Okay, and there's usually units here, so let's say meters. That's meters. Great.
Yeah.
But more often, and they used to give this problem at PEMA all the time. They'd said your windshield, or no, it was like a lawnmower. It was a sprinkler. It was like your sprinkler has an angle of 135 degrees of rotation, and your yard is 40 feet. They wanted to know this length here, this s. Well, the problem is s is really circumference, and circumference is 2 pi r, but that's only true if you go all the way around.
Yeah.
So I prefer this formula where it's your angle out of 360 times 2 pi r. I find it's more memorable here.
Mm-hmm. That's what we were taught in class.
Okay.
Oh, do you want me to solve this?
Yeah, go ahead. I'm sorry.
Oh.
Yeah, I'm sorry. There's a bit of unclear. Yeah.
40 squared. That's not a nice number. Oh, it's 100. 1,600. Can I use a calculator on this?
You can, but you should be able to reduce 135 over 360.
Oh, yeah. By 5. Over. It's 32 over 72, and then we reduce that. Correct?
So it should be 135 over 360 times 2 times pi times 40.
Yeah, and so it's 1,600 pi, and then I'm reducing 135 over 360.
Well, okay, so this is something you should do more of. Is you should divide before you multiply. And for example, like that 0 goes with that 0. 4 goes into 36 9 times. Right, like that.
Yeah.
So 135 times 2 is 270. 270 times 9. I mean, that's a little more doable than especially if you don't have a calculator.
Yeah. Oh, okay.
I mean, you can use a calculator any step, but this is
It's what I got was 2,160 pi.
great. Feet. Don't fit your units on these.
Oh yeah,
because,
feet.
They will definitely be there. Okay, so
Wait,
then
is it feet squared or just feet?
I'm just asking for a length, a walking distance. That's why I draw a person walking along, because it's literally a walk. It's how far did you walk? I walked 2,165 feet.
That's what I tell my friends all the time.
Yeah.
I run 2,165 feet all the time.
So let's do another problem here. Let's say I give you an angle here. Your angle is 7 pi over 6, and now I want the area. The radius is 12. So the area of a sector is equal to, and again, I do it the same way. Pi r squared is your area of a circle. It's your angle out of 360. Yeah. Okay. Now, however, there's a slight modification of this. If you want to keep this in radians, you have to convert your angle to degrees. I'm sorry, to radians. So your angle is you would multiply by pi. I'm sorry, over 180.
Yeah.
I'm sorry, 180 over pi. Let me doing this wrong. If we go 180 over pi, and what that does is this cancels, this becomes a 2 on the bottom. So it's 1/2 your angle r squared when you're in radians. I don't like remembering that formula, but that is true. So these both work. This is in degrees, this is in radians.
So I'd say 7 pi over 6.
Yes. So 7 pi over 6 is 210 degrees. So the first way is it's 210 over 360 pi.
You just know that.
Well, you will too. Use lots of practice. The second one here is 1/2 7 pi over 6 12 squared. Okay, so they both have a 12 squared, and they both have a pi in it. So what we're coming down to is this is 7 over 12 here, pi 12 squared. Is this 7 over 12 pi squared over here? Is 210 over 360 7 over 12?
Yes.
It is.
So I'm really confused though.
Well, I'm giving you two different ways to do the problem. But I'm emphasizing that I would use this first one always, but you could remember the second one for radians.
Okay, so how do I get 7 pi over 6 though into degrees?
So we covered that sort of earlier, but we'll do a few more here. So if you have an angle in degrees, and you want to go to radians, you multiply by pi over 180.
Okay, that's what
If you want to go this way, you multiply by 180 over pi.
Okay, so we multiply 180 over pi times 7 pi over 6.
Yes.
Okay, those pi's cancel out, and then 6, 8, 180. It's like 1 and 30. So you get 210 degrees.
Mm-hmm.
Okay, that's easy.
So the reason I brought up this discussion is that you might get an angle in your class. You might say convert from radian to degrees.
Okay.
And it might say 4 radians. Well, the thing is that you're used to there being a pi, but there doesn't have to be. So you still take 4 and you multiply by 180 over pi. So your answer is 720 over pi degrees. And that's uncomfortable because it's usually you think of degrees as not having a pi in it, but it can.
Yeah, but it can. Yeah.
And similarly, I can say convert from degrees to radians, and I can tell you, I measured, I got my my protractor out, and it's 30 pi degrees. So you're going to take your 30 pi and you're going to multiply by pi over 180.
Okay.
And again, this creates an awkward situation because it's 1/6 pi squared radians.
Yeah, that doesn't sound right.
Doesn't sound right, but is correct. And your school in the past has asked these questions because they're trying to emphasize like it can be these weird things.
Okay.
So now, in regards to the area of a sector, I gave you 2 formulas. I said it's the angle over 360 pi r squared, or it's the 1/2 the angle r squared. This is analogous to if I gave you a box and I said, what's the area? You would say
Base times height.
But it's also 1/2 diagonal 1 times diagonal 2.
Excuse me, what now?
Well, and I think that's what you're confused about. Is there are 2 different ways to get the same answer, but you know you're used to using that, but this is also equally valid.
How does that even happen, though?
Well, it's for another. We can do it for another day. It does work, and both of these work. It's just like the reason this one's useful is what if I give you the 2 diagonals? Well, you don't want to go find the base and the height. So this one's useful on the bottom here if it's already in radians because you already have it in radians. You don't have to do any other work.
Mm-hmm. So if it's in radians, you think I should just keep it as that?
I tend to convert it because I don't remember. For some reason, I can't remember this formula.
Okay.
I think in physics it's used more often, so it's easier to remember. But I don't do much in physics, so I tend to just remember one thing. It's easier to remember one thing, and then how does it lead to another thing?
Yeah.
And try to remember both things and figure out when to use them.
Okay.
Your brain creates these paths, and you can learn things that way.
Uh-huh.
Okay, so let's get to what your original question, the original thing you said, hey, I'm really struggling with. So there's all these different things in a circle that they can do. So let's pull up a nice looking sector and let's cut it. Let's see what you can get. So this is the sector. It's like an ice cream cone. You can actually cut it right here.
Yeah.
And this makes a triangle.
Mm-hmm.
So do you remember how to find the area of a triangle?
1/2 base times height.
Base times height. So sometimes that works because they give you this is 90 degrees here. Sometimes they give it to you where this is 60 degrees. So do you remember how to find the area of an equilateral triangle?
Yeah, it's like 1 side times 3.
One thing you can do is break this down the middle and make two right triangles.
1/2 times 1/2 times base times height.
So this is radius here. Okay.
Oh, right, yeah.
And this is radius over 2 up here because this is if it's 60, 60,
Oh,
60.
you're genius.
So the area you can find the area of the whole thing because this is r across here. So it's 1/2 r, and then you just need this side here, and it happens to be r over 2 square root of 3. So sometimes you remember this formula as r squared square root of 3 over 4 r squared. But you don't have to. You can use your 30, 60, 90 triangle stuff here.
Yeah, okay.
All right. So you asked about this though. You asked about the
donuts.
the donuts. And again, like you can do the same thing where you can actually cut it. Sorry, that was drawn really poorly.
No, I got.
Um,
If you think that's drawn poorly, you should see how my instructor draws. Yours looks so much better than his.
well, let me just do a little better job on this one. So, okay. So you can actually cut this thing in a way where you could be asked to find, any of the things we just found, but this is the common area that they're asking you to find, this sort of filled in there. Is that what you're seeing, or are you asked to find the whole donut?
I'm asked to find the whole donut.
Okay, so we can do both.
I'm asked to both. So
Okay.
usually what happens is we have to find one section and then we have to use that section to find the rest of the donut.
Yeah, so let's say the radius here is, this is one way they can ask it, 4, and they tell you that this distance here is 2. So the area of the donut is 1/2 big pi big R squared minus 1/2 pi little r squared.
Yep. Okay. Yes, I've seen that formula. When we learned this,
But more generally, it's the area of the big circle
minus the area of the little circle.
Yeah, and if you remember that, you know how to find the area of the circles.
Yeah.
So you don't have to use big R and little r. This is 1/2 the radius of the, and that's why they draw it this way, of the big one is 4 plus 2.
Okay.
So it's 6 squared minus 1/2 pi 4 squared. So this is 36 pi, 1/2 of that is 18 pi, minus 16 pi cut in half is 8 pi. So we get a total of 10 pi for that. Let's try another one here. So sometimes have you been doing much with like, okay, so let me draw another one here, and you can tell me if you've seen something like this yet. So they tell you that the radius of this one is x minus 3, and the radius of this one is, whoa, that was drawn bad, is x plus 3.
I don't we probably I think we've done one, maybe two problems like this.
Okay, it's the same thing though. It's area of the donut, or the ring. It's really a ring. Is 1/2 big R. What is big R in this case? X plus 3.
X squared. What?
Yep, because the big radius is x plus 3. The little radius is x minus 3 squared.
Okay.
So do you remember how to expand a binomial? And the correct answer is you rewrite it so that you don't miss terms.
X plus 3, x plus 3, yeah. Yeah, I did that like 100 times with you because I always forget how to do it. Okay, so let's solve this. 9/2 pi times x squared plus 9 minus 1/2 pi x squared plus 3. What? Oh no, plus 9. Okay, so I am confused. It looks like they're the exact same triangle. I mean the exact same length.
Well, this should be 1/2 pi x squared plus 6x plus 9 minus 1 pi x squared minus 6x plus 9. And then you can actually factor out the 1/2 pi, x squared plus 6x plus 9, and then subtract x squared, add 6x, and subtract 9. You're just distributing this negative in.
Yeah, I just did that wrong. Hold on, so it's 6x plus 9. Okay, minus x squared plus 6x minus 9. So what I'm getting is 1/2 pi times 12x. Yep, times 12x.
Which equals 6x pi. So it actually works out really nicely, believe it or not.
Yep, I don't think I've done one of those before.
You understand the principle here, that it's just the big radius minus the little radius. So sometimes they give you a word problem. Let me see if I can type one in here that's meaningful. So they'll say it's a word problem. Why isn't it typing? And I'll make the text a little bigger. So it's a builder has been asked to make a jacuzzi that is 12 feet in diameter, and the customer wants a 3-foot flagstone walkway around the tub. What or how much material in feet squared is needed for the sidewalk, I guess is what it would be called. So if it's not clear what I'm asking, I can draw a picture, but this is kind of your annulus word problem thing that they would ask you to do.
Okay, let's see if I can do this. So the jacuzzi is 12, so it's, okay. Let me draw my 2 circles. My donut. Okay, so from the first one out, it's 12 feet. And then from that part out, it's 3 feet. Correct?
Yes.
Okay. Enough pi times minus 1/2 pi. So it's 144 halves pi minus 9 halves pi. And I didn't reduce 144 over 2 because 9 doesn't reduce.
You still should your answer should be
I know it should be reduced, but
yes.
So it should be, so first, like when I did 144 over 2 pi because 9 won't reduce with 1/2.
So I did make this one. I mean, I threw in a little wrinkle. The diameter is 12, but the radius is 6.
Oh.
And then this is 3. So the big R here is 9.
Yeah, I didn't catch that.
Yeah. Always trying to put in a few little extra wrinkles. So it should be 1/2 pi 9 squared minus 1/2 pi 6 squared. And you do have the same problem. You end up getting 81 over 2 pi minus 18 pi, which you can convert the second one to 36 pi over 2 and get your answer of 45 pi over 2 feet squared.
Okay, I was on the right track. I just didn't realize the whole diameter thing.
Yeah. Okay, well, this is a good place for us to end the lesson today. I'll send you the notes and the screen recording out shortly. Thanks again for scheduling. If you want to do this again next Sunday, I would encourage you to schedule today. That way you get the time you want for next week.
Bye. I'm going to do that right now.
All right. Thanks, Zane. Have a great day.
Yep, you too.
Okay,
Bye-bye.
Bye.